Hello students, welcome to my YouTube channel UPSU Technical Center once again. Today's topic is how to draw step down chopper with R load with the help of MATLAB Simulink. For the drawing of step down chopper, here we need three parameters. One is called DC voltage source. Another is IGBT switch. Another is R load, as our requirement is only R load. Okay, first one, we have to select DC voltage source. How we will select? Click on the blank space, write down DC voltage source. Here already displayed on the pages. DC voltage source, we have two options: DC voltage source, DC voltage source. Here the DC voltage source, electrical specialized power system oblique source. We have to choose this one. Again, next one, this is electrical additional components oblique spice sources. This will not be taken, it will be wrong. First one is correct, so this will be under source, and this source under specialized power systems if we go through the Simulink library. Next, what will be the value of this? This value is 220, we have taken from the formula. Next, IGBT switches. So just click on the blank space and write down IGBT. We will get this. This is a 4 terminal. Two terminal is connected to the others parameters. One terminal for input and other terminal for the outputs. Okay. So for the better understanding, I am I am just drawing this IGBT. Okay, and you will get this IGBT only. Here is, look at here, this is the inputs to be there, it will be output, so it must be connected to any display or any scope. This will be connected to the parameters, and this will be connected for the pulse generator as per requirement. Okay, and click on this. There is the options is there, resistance RO on is there, forward voltage, inductance is not there, initial current, now resistance, now capacitance, all things are things there. But here the forward voltage of 1 volt is there. Let's check what I have taken in my numerical. Delete this. So here, first of all, look at here, double click on this. Here the forward voltage drop is 2 I have taken, so this is okay. Next, resistances. Here the resistance is R is there, the value is 10, but this is series RLC branch. So what will be the actual look of series RLC branch? Series RLC branch is here. Look at here, this is an horizontal, this is now in horizontal mode, and it has RLC both. So to rotate this, you just do the control R, it will rotate automatically, and afterwards you click on this. Here is a branch type, so select only R, you can apply and OK, you will get on the only resistance. Okay, so this way you can select R. So now delete this. Afterwards you have to do what? You have to connect. So for understanding purpose, I delete these all the lines. Let's check how to connect these things. I think it is well known to all of you. So delete these all the lines. Okay, so how we will draw? Just you get a plus sign and is connect to this blue line. So here it is a very simple way, and if you do this, you can complete the closed path. Okay, in this way. Next, pulse generator. So simple things. Here is the pulse generator. Here is you will get some parameters, some values that the amplitude is 1, period is, actually we have considered 1000 frequency, so period will be time period equal to 1 upon frequency, that will be 1 by 1000. Okay, and the pulse width is 50, that is 50% is there, and you get all these things and you click on OK. And pulse generator we also bring in some way. Click on the paper, double click, and you write down the pulse generator, you will get this, and this will be connected to the input side of the IGBT switches. Okay, next we'll bring the bus selectors. Click on here the bus selectors. There it is connected to the IGBT current, IGBT voltages, but we consider only IGBT voltage. Okay, that's okay, that's okay, there is nothing. So here it is connected to the output of the IGBT switch, and from this IGBT switch it is connected, IGBT switch is connected to the bus selectors, and the from bus selector it is connected to the scope. Okay, next things we have chosen the multimeter. Here is the very beautiful things. With the help of multimeter we measure the RLC branch, that means the load voltage and current at a time. So here at the time of resistance selections, here is the option for the measurement. You select branch voltage and branch current, otherwise we will not get the two options for measurement purpose. Now this output from the multimeter is come to the dmax. It is dmax, it is the option for two output. So you can do this. Okay, so very simple way, very simple way. Okay, now here there is a problem of load voltage, load current you can measure in this way, and the pulse generator output you can measure in the direct way from here to the scope. So these are all about the connections. Here is the terminal. You can click on this. There will be option to write the gate signals. Then if you write in such a way, these gate signals option or the notification will come to the graph. If I run this, you will see overall. Okay, so first things, save this. Okay, next run this. Okay, so here is a some graphs will be there. Look at here, is the graph, this is the output, and here is the provisions for the four graphs, and these are being done with the help of these symbols. This is the configuration properties. Select on this. Here is the number of ports as per your requirement. Here we need for the four graphs, so you write down 4, and all those parts are keep it as same as before, no need to change. Okay, and here is the option for the option for this. Here is the option for this. You see, in this way you will get the graph. If you select in such a way, then it will show in the horizontal purpose. So this is the things, and here is a view options, and the style option is there, and this style option you can change all the color of the background of the graph, and the thickness of the graph, color of the graph, and the background color also defined by these style options. Okay, this is for today's lectures. And if you want to analyze the graph, that is the height of the actual voltages, you have to go there. Okay, so this is zoom y. You click on this graph, click on this graph, just wait. Okay, click on this graph. Just need to wait. Just on put on this. Look at here, this value is 280. In this way you can measure the voltage, and this current value you can measure the IGBT voltage. Okay, thank you very much for today's lecture. If it is profitable and valuable, give a like, share, and subscribe those are new for this channel. Thank you very much for today's lecture. Thank you.